Sean is going to be here to explain to how these carts work. But we've already looked at wind energy when we went through the iFly. We kind of looked at coal energy. Anybody who remember we went to the museum? That was a little bit dry, but we learned that as well. One of the things we're going to learn about is how the EV world works, starting with some of our go-karts and how they're powered. So I'm going to let Sean take it away. Just
what does EV stand for?
Oh, electric vehicle. I'm sorry, electric vehicle. Electric vehicles. All right, you guys know how they No, you're just going to learn how they work.
Uh-oh.
Alright, just come on in here, come in here.
Alright, you guys, try to squeeze in here real close. You guys can all take a look, okay? So, a Tesla that you see driving around on the street is almost identical to this little cart right here, okay?
Wow.
These run off of 48 volts. If you come back here, you can see it's got an electric motor, alright? There's a controller, and then there's the mechanical parts, so the brakes, the steering linkage, the chassis, that kind of stuff, right? The motor is a 10 kilowatt motor. Makes about 30 horsepower, right? This cart is 400 pounds. You can go roughly 48 miles an hour with these 48 volt lead acid batteries, right? We have an option, not really here now, but these carts have an option to run with lithium batteries. Lithium batteries are a lot more efficient about how they put the power out, and they can put a lot more power out in a very shorter amount of time compared with lead acid. So lithium batteries can propel these cars 70 miles an hour, right? They can go for about 10 to 12 minutes in between charges, give or take, depending on how far you use and how we treat the batteries. Here, we put a focus on getting races out on a real consistent basis. So we have the cart set up to do about 14, 15 laps. If we know what we're doing and we have enough time, we can tweak the batteries to get almost 20 to 30 laps out of it. We don't do that all the time, right? So there's 4 batteries. All right, you said electrical engineering, right?
Yeah, I got a few. Where's
So
right there? I got electrical engineering right there.
All right, so how are they hooked up if they're 48 volts? Serial, right? Right? So that means that power to get that voltage is running through each one of these batteries. If there's a problem with one battery, you feel it in the whole part. It affects all of it, right? And then these right here are our chargers.
Charging
If you look, you'll see there's a little display. All right? Because it's a 48 volt battery, they start charging about 56 volts. And they slowly come down to about 52 volts by the time the batteries are full. Now that's a little more than 48 volts. Because these batteries, they're rated 12 volts, but that's 12 volts when they're empty, right? That's not their charge voltage, right? So these chargers can push almost 40 to 50 amps of current into the batteries while they charge. That's how we get the cars to charge up every 8 to 10 minutes.
So it's like the Tesla superchargers almost.
Yeah, I mean, they put funny names on stuff, but the technology and what's going on electrically is exactly the same. It doesn't change. So if you have an electric golf cart, exact same running hardware. If you have an electric forklift, exact same hardware. They tweak the motors a little bit to advance the timing to make the motor go faster, but that's at the expense of like torque, right? Because it's always give and a take with electric motors and stuff. But if you go driving past the warehouse and you see an electric forklift outside, it's the exact same stuff, right? There's not some factory out there somewhere just making go-kart stuff. They make motors, and then you tweak the motor depending on what kind of application you put it in, right? So if you look, we got all these chargers hooked up, right? We're hooked into the power grid. We also, on the roof of this facility, which is unusual for a go-kart place, the entire roof is covered with solar panels. So on a sunny day, about a third of our electrical needs are covered by the sun, right? Not by nuclear power plants, or you were saying coal power plants, or whatever else we have around here, right? So on a sunny day, we can kind of clap ourselves on the back that we're running nice, clean energy, nice, clean facility. All right?
Any questions? Anybody has any comments? Anything you want to add to it? Perfect. Well, don't say we didn't learn it. Y'all got a chance to see it. I have a quick question. If you got anybody see one of these in your car before? Anybody seen a battery in your vehicle?
Mhm.
Right? What happens if you put the two together? If you put the red, the negative, and the positive wire together, what happens?
Spark.
Sparks.
Instead of electrical engineer, you're now a welder.
Right.
So it's important that you know, because at one point somebody's going to change their battery, and you're going to need to know that it's going to look something like this. Okay. So any questions? Anybody else? Perfect. Thank you. Thank you so much.
Thank you
Ron.
so much.
Thank